Okay, so I'm just going to talk about this outside of the context of PID as such, because I think the first thing that's really important to understand is that the words for the controller action, specifically what I'm talking about is, so this is like direct versus reverse action. So this is the idea. There's a lot of confusion on how this works. It's confusing only if you think about it in context of the traditional control block diagram. But when you think of it from the point of view of a controller unit, a controller box, it becomes actually really easy to understand. So remember that we have a plant that we are trying to control. And if we buy a controller box, that controller box will be connected to the plant, and it will be connected in such a way that over here we can actually talk about the controller output. And the way that I've drawn it here is I've drawn it such that it's basically the same as the manipulated variable. I am absolutely dying. Is anybody else super hot? Let me see if this is like... So the controller box, now when you just think about this from the point of view of that machine, there has obviously to be some way for the controller to affect the plant. And I've drawn it here with the controller output just being directly connected to the plant. But you can imagine that in most cases there's going to be some transduction happening. So transduction, if you remember, is this word for changing the kind of an energy, right? So transducers are things that change, for instance, like a pressure signal into a current, or a current into a sound, or a sound into a voltage. Every time you have something like that, and so in a certain sense, everything that you kind of have thought of as a sensor is also effectively a transducer, right? Like it's transducing one kind of energy into another kind of energy. And so controller boxes, modern controller boxes are electronic in nature, so they're going to be working with electrons, but electrons by themselves need some kind of transducer. If I bring about the movement of electrons in the controller box, right, it's unlikely that the plant, just in terms of like tanks and flows and so on, that electrons will directly influence the way the plant works. And so I need some kind of a transducer there. And that's, when you read through the textbook, that's one kind of source of confusion. People are confused about what's the controller output and what's the manipulated variable. It's perfectly fine if you kind of imagine them to be the same thing, because conceptually the controller is actually moving a valve. But there's, you just kind of have to imagine that there's more between the controller box and the valve than just a wire. Right, like there's a wire and there's a transducer and then there's like an air line and there's a whole lot of extra stuff happening. I'm drawing this from a very high zoom. If we zoom in on that line over there, right, you would have like a milliamp signal, which would be converted through like an I to P converter to a pressure signal, which would go to a valve. Typically a valve in chemical engineering, and that valve would actually be changing a flow rate, and that may be the thing that we actually call the manipulated variable, may be like a flow into the valve, into the process. But from a very high zoom, controller affects the plant, right? And the plant then responds, and we're trying to figure out, we're trying to control a particular variable. Again, there's the same kind of provisos. We cannot simply look at a flow, right? Like we can't just put the box in front of a pipe and say, right, just go for it. Because again, the box has to be connected to that flow rate in some way or that level in some way or whatever. And so there's a whole set of equipment there. There's a sensor that senses the level, and then there's a transducer that takes whatever that level sensor gets out and translates that to something that the controller can understand. But again, from a very high level, and again, notice I'm not drawing a formal block diagram here. I'm just focusing on the way that the information flows around the system. Yes?
With this output, you've got this control variable, which we want to measure. But we describe the control variable also as the measured variable.
Yes.
The output of that transducer.
If you are doing feedback control, in basically every case that really is important, if you are building a feedback control loop, the measured variable is the control variable.
So you don't look at the output of the transducer as like the measured variable.
No, well, so again, there are layers, right? So it's mostly a case of semantics, in the sense that if you look at and where it becomes important is, and this is true, there may be some dynamics associated with the equipment that you are using to measure the measured variable. And so the distinction that we will draw there, so this is the output of the plant, or maybe the controlled variable, right? And we may say that this is the measurement, but we are attempting a measurement of this variable, right? So we are saying, we wouldn't say that again, if we were just speaking about this, if I told you that I was trying to control a level in a plant, if I knew that my level measurement was kind of patchy, it was slow or it was noisy or whatever, I would still say that I'm trying to measure the level. I would just say that my measurement is delayed. And so there's a difference between the value that I measure and the variable that I am attempting to measure. Is that clear to everybody? So when I talk about the measured variable, in feedback control, we always attempt to measure the thing that we are controlling, right? That's always what we're trying to do. And now you may say, but when would the measured variable and the controlled variable not be the same? And typically that would be if we're not doing a feedback control scheme. So in other words, if we are doing a feed-forward control scheme where we're trying to use some other measurement in order to make a change to something that we're trying to control. In feedback, this is what I'm trying to tell you. The simple thing is, in feedback control, in a simple feedback control scheme, we always measure the variable that we're trying to control. And again, well, maybe, there's a lot of tryings in there, right? Like, so we try to measure as accurately as possible the controlled variable that we are trying to control as accurately as possible. Because you can get into a lot of semantics. The controlled variable may not actually be well controlled, right? So it's all about what we're trying, it's like our intent. So our intent is to have this plant output at some set point value, right? And that makes it the control variable. The fact that we have a target or and a design to control that variable, the fact that we want to control it makes it the control variable, not the fact that it is correctly controlled, right? So it's what we're trying to do, not how well we do it. And again, because we're trying to control it, we are also trying to measure it. And there may be some dynamics in there, and there may be some noise or whatever, but and it's useful, therefore, to distinguish between the actual value of that variable, right, and the measured value of that variable. So we can make that distinction. That distinction is useful to make. And it's important to remember that the controller box, in general, does not in fact see the actual value of the controlled variable. Is that also clear to everybody? Just because of all of the stuff that's in between, we can basically never truly know exactly what the value of the controlled variable is. We can try, but we can't actually know. Okay, so those are just the parts, right? So this is the feedback control loop, and it's only when you look at it in terms of this, if you forget about the math for a second and you just look at this idea, and what I find very useful to reason through actions and gain signs is starting at this idea, which we always start at, where all the variables are always at 0 when we start, right? So everything starts at 0. So we always imagine things are going well. We are achieving our control goals. Why do I say things are going well? Because remember, everything is 0. The output is at 0. The controller output is at 0. The manipulated variable is at 0. The controlled variable, everything in the whole diagram is at 0 in the linear world that we live in, right? So it's always easier to think about deviation variables when we think about these signs. And then we simply ask ourselves a question. The question looks like, if one of these things were to become positive. So in other words, and I think the easiest one of these to imagine is, after having been really good for a while, at some point, through no specific action of our own, the controlled variable goes up. Why would that happen? Because it always happens, right? It always happens that something affects the controlled variable. If this was not possible, right? If the controlled variable would never move under its own accord without us telling it to, we wouldn't need a control system. Okay, so we need a control system because from time to time, the wind blows the car and we find ourselves drifting across the lane. Or from time to time, it rains and we find that the reactor is getting cold or something like that. There's 1,000 different things that can have an effect on a controlled system. And so we just ask ourselves, at some moment in time, what if the controlled variable suddenly became positive? And I'm just going to ignore again the measurement because that gets in the way of the basics of this action, right? So we have to ask ourselves, for this particular plant that we're looking at and for this particular manipulated variable that we're looking at, what should the controller do to get our system back to 0? The controlled variable has become positive, right? It has moved up from where it was. And now we want to know, should the controller open the valve or close the valve? And now you should imagine, or you can kind of see that it depends. I haven't given you enough information, right? You first have to know what would happen under those conditions. And again, when we think about the positive idea, we can ask the question, well, for this particular plant, and let's do 2 different examples, right? Like we'll do 2 different varieties of the tank system. So we have our good old friend, the tank system. Okay, and imagine that the controlled variable is the level. We're trying to control the level. And in the one case, the level controller is connected to the outflow of that tank. And in the other case, the level controller is connected to the inflow of the tank. And you can see that those are very possible solutions to this same problem. I mean, if you really want to maybe, like if you want to make this like, you can imagine there's a pump there, you know, just if you kind of want to make sure that this is something that makes sense. Now you can imagine, and again, I'm going to take the easiest version of this where when I say the controller opens the valve, that's an increase in the controller output. Okay, we can get into other local actions later, but the most important idea is when this valve opens, the flow goes quicker into the tank, which means that the level will rise. Okay, and so here, the system gain is positive. Okay, the system gain here saying this is the plant, we have valve opening going to level, and that gain is positive. When I open the valve coming into the tank level goes up. In this system, which again, we've got the same general idea, right? We've got valve opening. So this is positive, and this is negative. Okay, so notice that you have to know the picture, and you have to know a lot of information here to kind of understand what that gain is. But I'll basically say, okay, that means that when I do a plus here, right, that becomes a plus. And when I do a plus here, that becomes a minus if we're talking about deviation variables. So in deviation variables, assuming that things started out at 0, if the input becomes positive, in that case, the output will become negative. Okay, so that's the gain of the system. And so now we have to ask ourselves, what would the controller action need to be in both of these cases? And to understand the controller action, again, notice I haven't drawn a reference signal comparator. I haven't shown you how we're subtracting any kind of set point. I'm only focusing on this connection. The connection says what is connected to the controller is a measurement, and what is coming from the controller is an output. And from that point of view, if the controller has to open the manipulation when the measurement goes up, that is a direct acting controller. It acts in the same direction as the measurement. When the measurement goes up, the output goes up. That's direct action. Okay? Reverse action is when the measurement goes up and the controller action has to go down. Does that make sense to everybody? So the direct and reverse, and the reason why I'm doing this without the comparator is that the direct and reverse, that terminology predates. That terminology predates the terminology of proportional control calculations. Right? People built controllers before they could do the math of controllers. That's just a fact about reality. So the Watt governor was built and used before anybody could analyze why it was doing what it was doing. And so historically, we have this kind of old set of nomenclature which has to do with just the way that things are connected together. And so let's just analyze in detail now from this point of view what the controller action will be here, because in the left-hand case, remember I'm now measuring that level, and my controller, under the conditions of, okay, maybe I'm going to redraw this. So that's the diagram for the plant itself. I'm going to redraw this so that we can put in different signs. I like doing these signs. They help to clarify the controller action. And so we're analyzing first the left-hand side case where the valve is on the input side. And we're asking what should the controller do? What should the controller do if this becomes positive? And the answer is it should close the valve. If the level goes up, the correct action for the controller is to close the valve. Okay, and so this is a reverse acting controller. Right? And let's do the same thing now for our right-hand side case. In this case, now I'm going to just draw. Notice that it can be confusing when you start drawing these things, when you start drawing these signs, because there's going to be then a reaction from the plant, and you can kind of get caught up in chasing yourself around the loop. If you, so because you can maybe ask yourself, well, okay, so the level went up, so I closed the valve, but then the level went down because I closed the valve now, and now I should be, just break that loop. Go once around the loop. My recommendation is when you're trying to figure out action, just start at the start at the controlled variable and move around until you have figured out the desired manipulated variable. And that'll allow you to reason about the controller action. Okay? Let's just do the same thing again for the other one. Okay, so in this case, remember we've got a different situation. Right, we've again got the same controller, but now when the level goes up, we have to open the valve. Right? And so the controller is acting in the same direction as the controlled variable. Those signs are the same, and so that's a direct acting controller. So the reverse and the direct is from the point of view of the controller looking just at the measurement. Am I moving the valve in the same direction as the measurement or in the opposite direction as the measurement?
I wanted to ask something else.
Oh. Yeah, so the direct and reverse is like, am I moving opposite? Am I kind of moving to counteract? Or let's say we're always moving to counteract, but like what does that counteraction look like? Do the actions move in the same direction or do they move opposite to one another? If they move opposite to one another, it's a reverse acting controller. If they move in the same direction, it's a direct acting controller. Okay, yes?
So that's the second illustration here. If you say that the level goes up in the valve,
Yes.
that continuously
Yes. So this is now, this is why I'm trying to draw these little lines, the squiggles here, right? Is you're gonna get yourself very confused if you then continue around the loop, right? Because actually, if you want to go stepwise, you would say, well, okay, the level went up, so the controller opened the valve, but when the controller opened the valve, the level will go down. And that's true. That is perfectly true. But so when you step on, don't step all the way again around the loop. You'll just confuse yourself. Okay? So the question is really at that moment, starting at 0, if the controlled variable at that moment is positive, right? What should the controller do at that moment to make everything better again? Okay, we're not saying what will eventually happen, because eventually the signs will be flipping all over the show. As with integral or whatever, like there may be moments where the controller is opening the valve and the level is going, like the controller doesn't always do perfect control. And so you have to kind of not think around the loop. So remind yourself that you start here and you go around the loop, but you stop there, right? So you only do that up to there and you stop. You don't analyze further around, like you don't keep going around the loop, because then you'll see maybe it's a plus, maybe it's a minus, now it's a minus, you know, like then you get very confused. Just go, okay, plus, plus, yes.
Okay, I thought that answered myself. I just wanted to know, is there a correlation? Can you like say if KC is positive, then you are having a reverse acting controller, or is it not always the same?
So, okay, it's complicated. Okay, and let me explain why it's complicated. Because of all these additional things that I'm not drawing in this loop. Okay? So technically, when we are talking about the controller action, we have to be thinking about what's coming out of the controller, which would be that actual milliamp signal. And so when you're talking about the sign of KC specifically, you have to kind of, there's a whole lot of information that you need to give me there. What is the other stuff in the block diagram and what are their signs? And why am I saying that these signs could be different? It's important. Okay, so here, I hope I'm just going to draw a line behind the controller action. Is everybody cool now with controller action? Okay, this is the rules. Remember that the controller action is relating the measurement, what like the measurement is, to what the controller action is. Now it becomes complicated. Let me explain why complications can ensue. I can have a positive in terms of the milliamp signal, right? And then I can relate that to a pressure which is going to a valve. But I have a choice of valves. Okay, I can have a valve that when I increase the pressure to the valve, it reduces flow. And I can have a valve that when I increase the pressure to the valve, it increases flow. Okay, so the valve itself can have a sign. Now, in most cases, the reason why I focus on these very high-level diagrams is that the instrumentation engineer on site will probably have set this up in such a way so that the conceptual output of the controller is a valve opening, right? Where the controller will be sending like a percentage open conceptually to the valve. And so in many cases, you will actually not to have to think about this. Why the textbook forces us to think about this is because that is literally the actual mechanics that is going on. The controller is, in fact, outputting some electronic signal. That electronic signal is, in fact, being sent to a I2P converter, which is the thing that actually is connected to the valve, which then affects the flow. And so why this is important is if I suddenly change this valve from a direct action to a reverse action valve, in other words, a air to open versus an air to close valve, I would have to flip the sign of the controller. Right? Is everybody following me on that? And so on a high level, it's actually what I really want to be doing. I want to actually be thinking about it that the controller causes a change in flow. That's the zoomed out level. But on the low level inside, the way that happens is the controller outputs a milliamp signal. The milliamp signal is converted to a pressure signal. The pressure signal gets sent to a pneumatic valve. The valve either opens or closes depending on what the sense of the valve is. And the flow that results follows from. Now, the good news is that later on in the subject, we'll almost always just be on this top level, right? Where you'll hear me say things like the valve is manipulating, or you'll hear me say the controller is manipulating the flow. And I'll allow myself to just think that that's basically on the high level okay. The analysis of these lower level components is important though if you actually want to build a real thing. You have to take into account that the gain of the controller will be in kind of units of milliamps to milliamps. But it is connected to these other things, so the overall gain will be determined by the other components as well. So there'll be units. So you can ask yourself, like, for a certain change in the set point in milliamps, what would be the equivalent pressure change? And you can ask yourself what would be the equivalent flow change. And so each one of those answers has numerically a different answer, if only because of all the unit conversions, right? So the numbers would be different. And if you actually want to calculate the numeric value of the gain correctly so that all these intermediate signals fall within the correct values, if you want to simulate everything and you want to know what the pressure signal to the valve is and you want to know what the milliamp signal would be in milliamp, then you have to do this calculation that way. But in most cases, we are only really interested on that zoomed out layer. But it is kind of important to just ask yourself, like, where are we focusing? On the high level, like, I'm much more of a high level person, so most of the time when I'm talking about like the action of a controller, I'll try to be very clear about what the manipulated variable is, right? Are we manipulating a valve opening, right? In that case, I can actually say, well, when the controller is conceptually outputting a valve opening between 0 and 1, where 0 is a closed valve and 1 is an open valve, I've hidden from you the sense of the valve. But I've said, look, we'll just make it happen on the system. We'll scale everything so that whatever the controller outputs gets output so that 0 is a closed valve and 100 is an open valve. Right, so I've hidden that from you. If I say the output of the controller is a pressure signal, or I ask something like, what should the pressure signal be? And you'll see in the old papers and in the tuts, you'll see this difference between me saying the manipulated variable is just a flow straight, and me saying the manipulated variable, let's be really, really careful about this, is the milliamp signal sent to the I to P converter, or the manipulated variable is the pressure signal sent to the valve. When we're talking about the pressure signal sent to the valve sense is important. When we're talking to the flow, the valve sense is unimportant because I just want to know, like, what is the effect of the thing that I'm doing on the actual flow.